Okay, today in class, as you can see, it's got amino acids on the schedule. So today we will be talking about that, but one aspect as a review, we've seen, that's probably not going to show up. Okay. From last week when we look at these are what we call aldose sugars. Okay. Now, this is just an example. You don't need to be writing this down. Okay. We know that this is an aldose sugar because there's a double bonded carbon on our first structure. That's an aldose sugar. We also need to discuss what's called ketose sugars. Okay. In that case, this would be what we call a ketose sugar, and it's not because we have the same, what appears to be the same molecule on our first and sixth carbon, but because there's a double bonded oxygen in a separate location, and it's actually on, call our second carbon, okay? And then in this case, there's carbon 1, carbon 2, okay? Then we move on to carbon 3, carbon 4, carbon 5, and then carbon 6, okay? Okay, that's the correct orientation that I wanted. I thought it went back and forth like this, and we could do that. This is a ketose sugar known as ribose. Okay, so what gets to be a little tricky about this is there are still 6 carbons on this compound, but the structure is going to be different than that of aldose sugars. Okay, because what we see here, this is what we call a hexose. Okay. Oops. Okay. Because when you draw this out, there's your prefix that you're using, and of course it comes out like that. It comes out as a hexagon. In this case, okay, this structure is just a little bit different. It's also called, it's referred to as a hexose, but that's because there's 6 carbons here. But it's also a ketose-based sugar, okay? And this is where this is just a maybe slightly different. You could say maybe a little tricky, but we'll work on that together and we'll get you through it. Okay, so just like this example, you want to tip this on its side, okay? But as said earlier, this turns out to be a 5-side figure instead. Okay, so this is where it gets to be a little tricky, but if we use some prior knowledge, okay, carbon 1 on this aldose sugar, that's a hexose, was right here. Okay, there's that double bonded oxygen and a hydrogen on that carbon 1. Notice we don't have that double bonded oxygen until carbon number 2. So rather than writing this, this is what we're going to put on this structure, okay? So what that means then, here is carbon 1, CH2OH. And then, so here's carbon 1, carbon 2. So where would you presume that carbon number 2 is located? This way? Here? Okay. Logically, that would make sense. But you're using logic, but that's not where it's located here. Carbon number 2 actually located right there. Okay? So carbon 1, carbon 2, then we go 3, 4, 5, and then way out here on the end is CH2OH. Okay? So the same rules that apply, or if you want to say rules or what, procedure, or however you want to classify what it is you're doing from step 1 to step 2, and then finally closing it off in step 3. Okay, I'll just erase this now so don't get totally confused. So now on carbon number 3, where is the OH molecule? Up or down? Okay, so on top. Okay, then we move over here to number 4. That one's down. And then what happens here at number 5? Oops, on the right side, isn't it? Okay. I was just seeing if we were paying attention. Okay. And then what's way out on carbon number 6? Right there, CH2OH. Okay. So if you remember from last week, okay, what would you guess is here? Because remember last week you saw there's an oxygen atom there. Okay, so the same process would take place when these, you could say, it's a process called reduction. Okay, because these are known as reducing sugars. Now again, that's more so of a senior level application that we do, but in short, what's happening here is, again, these just flip-flop with one another, and then it's actually this oxygen here is what ends up there. Okay? So then everything else is just the same. We said for our practical purposes, when we see this, the OH is just going to go down. Okay? Then look at what we have left here. It's a little different than aldose sugars. We still have that CH2OH goes here. Okay? Then just go right around the corner. This is still the same. This would be the same. And then this is where they had flipped. So CH2OH is up top, hydrogen's on the bottom, and then this used to be an OH up here, but now it's just an oxygen, and that's how you'd close that ring off. And this is what we call fructose. So anytime you open up a soft drink, pop, soda, whichever, or in a soda fountain, that's probably one of the major ingredients is high fructose syrup. And that's the formula and the structure for that monosaccharide. So let's say, for instance, what is the process called dehydration? What does it mean if you are dehydrated? Your body is dehydrated because you've lost water, right? Okay. So what would happen if you saw deoxygenated? What would deoxygenated mean to you? Lack of oxygen. So what would this look like if we saw deoxy-3-fructose? Okay, so let me write that down. Deoxy-3-fructose. Okay, So what's happening on that third carbon, which is, here's the first, the second, what's happening right here? What would be lost? Okay, so within this circle here, or ellipse, or whatever you want to call it, what would be lacking in there? You just had said it. Okay, that would mean you just have two hydrogens there, which means that would be the case here as well. There would be no oxygen there. There would just be hydrogen and hydrogen. And that's what we see there. Okay? You're speaking for your classmates. Questions? Okay, so I'm just going to hit pause so I can erase this. And we're back. One last example, okay? First thing I want you to ask yourself, what type of monosaccharide is that? Is it an aldose sugar or a ketose sugar? Sure? On the first carbon. Ketose sugars have a double bond oxygen on the second one. Okay? So this, what we call ribose. Okay? So what's a little tricky about this now, okay? Keep in mind, how many carbons do we see in this molecule according to this step one? Okay? So what side of a shaped figure is this going to be? Right. What's tricky about this is ketose sugars, you can have 6 carbons, but it's a 5-sided figure. Aldose sugars, if you have 5 carbons, it's going to be a 5-sided figure. So in this case, okay. Now again, this is different than a ketose sugar. What would we see right here? Does it go down like this? The answer would be no, because that only happens in ketose sugars. Okay? So what we want to do here, okay, is put a double bond on oxygen, because that's where carbon 1's located. Then what's this telling us here? On carbon number 2, it's on the right side. Okay, so it goes down like this. Okay, same thing here. And then same thing here. And then way out at the end, what do we see out here? CH2OH. This is in step 2 again. So now we're going to go ahead and close that ring. And upon doing so, and should you have any questions, find someone like the young lady who just walked in. This was fun stuff, right? Otherwise, just lie. No thanks. This was fun stuff, right? Okay. Oh, I was going to say, well, just lie to me. Oh, okay. Okay, again, these switch. This is the oxygen that we see here. This goes down. Okay. What does this have to do with that? What is DNA? Oh, well, that can't be right. We must be talking about this. We gotta be talking about Dan, right? Or were we right the first time? Yeah. So what's DNA? That comes from Zootopia too, in case you're wondering. What's DNA? Right. DNA, yes, not DNA. So what is it actually, if you were to write that phrase out? Then I'm going to run out of space, so then, nah, I just don't want to do that. So this is pretty close to what would be the structure in your DNA. It's called deoxyribose nucleic acid. So it's the sugar that is a precursor for, you could say, making proteins or how your DNA sticks together. Okay, we better get rolling on the amino acids. Can we erase this? Front row. Don't even need to ask second row, because we already. Okay. Okay. Does anyone remember, does this look familiar? This is everything that we've talked about in up to here, but this was, I wrote this up there for the freshmen. It's just that in your case, you just had a very brief encounter with this. Aromatics, that means you're including benzene rings with that. But there's another organic family known as this. Amines, okay? And anytime you see the term amine, just means you have a nitrogen group, okay? And then usually referred to as NH2, okay? Because NH3 is ammonia, NH4 is ammonium, but in this case, this is an organic compound. And this is how I prefer that you write them. I mean, it's not wrong if you go like this here, but one of the things that was taught to myself is what column is nitrogen in? It's 5, right? So then how many valence electrons is that? It would be 5, okay? So then here's 1, here's 1, here's 1. So there's 3 of those 5. But how were you taught when you had unshared pairs of electrons? What did you do with that in a dot diagram? For instance, if you're doing that. Nitrogen can do something that all other elements can't do except carbon. It can triple bond. So what you would do, okay, but what would you do with those extra 2 electrons from each nitrogen? You remember? Would you do that? You're shaking your head no. That's how we want you to interpret that, because keep unshared pairs of electrons together, okay? So since there's 2 left in this, put a couple dots up there, okay? So then what can you presume that is bonded here? What are these atoms? If we're not showing anything. So NH2 is an amine group, okay? Then here's a carbon with another carbon. So what functional group do you have now on the right side? Okay, so put everything together with what we've talked about within the last, I don't know, 5 minutes. This side is called what? A what group? This is an amine group. This is what type of group? Put the two together. That's where that comes from, as an amino acid. You have this group on one side, this group on the other, and then if there's just a hydrogen on here, she's busy back there. This is called glycine. Okay, that's an amino acid structure. We want you to be able to do that. All amino acids have the very same structure except for whatever's bonded on that middle carbon underneath there. Okay. Then if we wanted you to draw the amino acid alanine. Okay. So for our practical purposes, we're going to start from scratch. I should write that a little lower. So from left to right, okay, we have our amine group, okay. Then that's bonding to a carbon with a hydrogen on top. Now we need our acid group. And again, this is how and why we call this an amino acid. We have the same molecule as what we see up above, but alanine has a methyl group attached to it. Okay? So then once you put a methyl group down here, which is a derivative, what is the formula for a methyl group? Okay? Now you have the amino acid alanine. Okay? And see, I gotta look at my folder here just a moment. Okay, I do have a paper for this. I don't have it up on the board here on plan books, so that adjustment will be made tomorrow. I'll hand that out. And then there's just one more we want to go over, and that is valine. Okay? So I'm going to erase all of this because that's the best way that I would be led to believe that we learn this, because for those of you who move on to take the biochemistry portion, there's only 20 amino acids, which there's, of course, what seems like an infinite number of proteins that are made from those amino acids, which is true. You're responsible for 13 of them, and we've only gone through, as you can see, this would be our third one. So from left to right, how do we start this? Nitrogen. Then what? Okay, bonds onto a carbon. 2 unshared electrons, that's right. Okay, and then another carbon with an acid group, so COOH. Okay. Is there anything on this carbon up above? There's a hydrogen And then, is that an amino acid right now? Yes. That would be glycine. Okay? If we had a methyl group on there, it would be alanine. Okay? So what is an isopropyl group? Okay? So this, in short, would be the molecular formula for an isopropyl group. But is there possibly something, you can't use that though, because we need an isopropyl group, not a propyl group. So what that means then, okay, if we say X marks the spot, okay, and here's a carbon here, this carbon-to-carbon bond is the middle one, and then a hydrogen goes down here, and then on both sides of them, we just don't have carbon and carbon. What else goes on these carbons? You said hydrogens, that would be right. So C3H7, remember this carbon is this one, okay? So what that means is 1, 2, 3, there's our 3 carbons, 3, 6, and 7 hydrogens, there's our 7 hydrogens. So we can just click this and drag it on down here. And there is your molecule of valine. And one of the things that we instruct you, or say maybe helps point the, or helps you remember this, is you can, for instance, do that. And then the reason that's important is you're taking this and turning it upside down, and it looks similar to an upside down V. Now, whether that helps you with valine or not, that I don't know. But if that helps you, use that to your advantage. Okay, that's all I have. We'll catch up to you next time with a paper tomorrow. And then I would be led to believe our exam is not going to be this week. We'll probably push that back to next week. But then even moving forward next week, I'm just trying to look at the schedule. Let's see here. A week from today is the Del Rapids invite. You leave at, say, 1:15 or 1:25. Okay. You'll be here for a little bit of that time, and then are you still going to Alcester? Okay, maybe it's just weather permitting. So again, I'm going to put a question mark on there, and we'll discuss that a little later on when we are all back together again. Catch up to you next time.